Good day everyone. Today we'll be discussing the physical properties and mechanical properties of rocks. A rock material is an aggregate of mineral particles. The physical and mechanical properties of rock materials determine the rock's performance under specific conditions. The physical properties may be known as index properties. This describes the rock material and helps in classifying them. On the other hand, mechanical properties may be known as strength properties as they give information about the performance of rock materials when subjected to a particular loading system. Physical properties: mineralogic composition, structure and texture, specific gravity and unit weight, density, void ratio and porosity, moisture content and degree of saturation, permeability and electrical and thermal properties, swelling, anisotropy, and durability. Mineralogical composition, structure, and texture. This is the intrinsic property controlling the strength of the rock. Although there exist more than 2,000 kinds of known minerals, only about 9 of them partake decisively in forming the composition of rocks. This includes quartz, feldspar, mica, hornblende, pyroxenes, olivine, calcite, kaolin, and dolomite. Specific gravity and unit weight. Specific gravity is the ratio of the density of solids to the density of water. The specific gravity can tell us, based on its value, if the object will sink or float in our reference substance. Unit weight, also known as specific weight, is one of the terms that, loosely speaking, describe and relate size, amount, concentration, and force, as well as specific gravity. Density, void ratio, and porosity. The density of an object in a given volume is a measure of how compact or heavy it is. The density of rock material varies and is often related to the rock's porosity. Most of the major rock-forming minerals in the Earth's crust, like quartz, feldspar, and calcite, have very similar densities, which is around 2.6 to 3.0 grams per cubic centimeters. Voids or cavities are open spaces in the ground that are commonly encountered as unforeseen ground conditions in engineering geology. Void ratio is the ratio of the volume of voids to the volume of solids and is closely related with porosity. The porosity of a material tells how densely it is packed. It is the proportion of non-solid material volume to total material volume. It decreases with increasing age of the rock and the depth of the rock. Moisture content and degree of saturation. Moisture content is simply how much water is in a product. It influences the physical properties of a substance including weight, density, viscosity, conductivity, and others. The weight of water in the voids divided by the weight of dry solids in the rock sample is the ratio of moisture content. The degree of saturation denotes the actual relationship between the weight of moisture existing in a space and the weight that would exist if the space were saturated. It can be calculated by dividing the total volume of voids in the rock sample by the volume of water in the void. The rock mass having higher porosity has higher degree of saturation. Permeability and electrical and thermal properties. Permeability refers to a porous material's ability to let liquid pass through its pores. Porosity and permeability are related properties of any rock or loose sediment, both related to the number, size, and connections of openings in the rocks. Electrical properties. The majority of rocks are dielectric, and measurement of dielectric constants are used to interpret data. Thermal properties. The increase in temperature also makes rock weaker due to the formation of cracks in the rock mass. Swelling, anisotropy, and durability. Swelling, the volume of a mass increases as a result of water suction or prolonged contact with water. Swelling is more common in weaker rocks. Anisotropy. Due to the sequence of rock formation, the properties of the elements of the rock mass are not identical in all directions. Anisotropic material has a weakness in one direction only. Sedimentary rocks, for example, have a high degree of anisotropy. Durability. Durability is the resistance to destruction. If rock is more durable, it means it will last for a longer period when put into use. It depends upon the nature of environment against which the rock is going to be used. Swelling index or slate durability test is used to describe nature of weathering. Mechanical properties. The tests are carried out on intact rock specimens in the laboratory or on rock mass in the field to determine the strength values. There are two methods used in testing the strengths: direct methods for calculating the above strength values in the laboratory, and indirect methods for determining the above strength value approximately in the laboratory or at the field site. These strengths include the compressive strength, tensile strength, and shear strength. Compressive strength. The compressive strength of a material is a measure of its ability to resist uniaxial compressive loads without yielding or fracture. Uniaxial compressive strength is given by the ratio of load at failure or rupture to cross-sectional area of the specimen. Direct methods. Uniaxial compression test. Applying compressive load until failure occurs in the core by a fracture in the middle using high-capacity compressive testing machinery verifies the uniaxial compressive strength of rock material and deformation behavior under loading. Triaxial compression test. Triaxial compressive strength is the strength exhibited by a rock specimen when it is subjected to confining pressure in addition to vertical pressure. Typically, at least 5 specimens are tested, each at a different confining pressure, to determine the peak strength. The Morse envelope can also be used to determine shear strength parameters of rock materials using these tests. Effects of confining pressure. Peak strength increases. There is a transition from typically brittle to fully ductile behavior with the introduction of plastic mechanism of deformation. Effects of poor water pressure. Transition from ductile to brittle behavior. Indirect methods. Point load test. The point load test is an index test that classifies rocks based on their weight. Other intact rock properties for which the test corresponds, such as uniaxial compressive and tensile power, can be estimated using the test. The strength ratio at point load in the directions with the lowest and highest strength index values is defined by the anisotropy index. The sample load and force gauges are part of the test instrument, and the sample measurements are also determined. Smith or rebound hammer test. It is commonly used to determine the hardness of a rock sample surface because it is simple to use and handle. The sample should be in the form of a core or a block, and the test is non-destructive. The best part of the test is that you can reuse the sample from the previous one. Tensile strength. Tensile strength of a material is defined as the maximum tensile which a material is capable of developing. In nature, rock mass is rarely subjected to direct tension, but it is subjected to tensile stresses. Rocks are weaker in tension. Direct method. In this, rock specimen is subjected to uniaxial tensile loading along its axis. The principal difficulties associated with tensile tests on rock is the prevention of failure within the grips and the elimination of bending in the specimen. Indirect method. For the indirect method, the Brazilian test of Mellor and Hawkes can be utilized. The Brazilian disc test is a useful technique to determine the tensile strength of a rock material. The Brazilian disc test has attracted the attention of a large number of scholars due to its extensive practical importance in engineering application. Shear strength. Shear strength is the maximum resistance to deformation caused by shear stress. Surface frictional resistance along the sliding plane interlacking between individual rock grains and cohesion and the sliding surface of the rock all contribute to the shear strength of a rock mass. Shear strength tests. It primarily concerns the shear strength and shear behavior of the rock's shearing and weakness planes, which hold a rock specimen together. This is the most expensive laboratory strength test because it necessitates a unique approach for collecting samples from the site as fracture planes to be tested, as well as the most complex testing procedures. This is a complete setup of shear testing apparatus with online acquisition systems. This is the end of our discussion about the physical properties and mechanical properties of rocks. The references are stated in the presentation for more information.